Welcome all. Now I am going to discuss question number 22 from the 2018 paper Electrical Engineering. The question is a 1000 by 1000 bus admittance matrix for an electric power system has 8000 non-zero elements. The minimum number of branches, transmission lines and transformers in the system are. To know the detailed procedure of how to formulate the Y-bus matrix is, audience can go through the given NPTEL video link. Let us discuss simply how to form the Y-bus. Here, explanation of Y-bus can be divided into formation of the diagonal elements and formation of the off-diagonal elements. So, first diagonal element. Here, first diagonal element is the sum of the all admittances connected between the node 1. For example, V1 is connected to Y11, Y12 and Y13. So, the first diagonal element is the summation of Y11 plus Y12 plus Y13. Similarly, Y22 is the summation of capital Y22 plus Y12 plus Y23 plus Y24. Similarly, Y3 is given as Y33 is given as Y13 plus Y23 plus Y34. Off diagonal element is the negative admittance of the transmission line connected between those two nodes. For example, Y12. Y12 is the negative of the admittance that is connected between node 1 and node 2. Similarly, Y13 is the negative admittance of the connected between V1 and V3. Here, V1 and V4 are not connected with any of the elements, right? So, Y14 is 0. And the thing is that this Y-bus matrix is symmetric matrix. Here, I1, I2, I3, I4 are the injected currents at the particular node. Here, V1, V2, V3, V4 are the terminal voltages at that particular node. Just now, we have discussed how to form the admittance matrix, right? Admittance matrix Y-bus is the diagonal elements is one procedure, off diagonal elements is one procedure. Diagonal elements is the summation of all elements, sum of all elements connected to the particular node. Connected to particular node. And off diagonal elements can be written as the negative admittance connected between corresponding terminals. Connected between corresponding terminals. Corresponding terminal, right? So, if there is no element means, no element between the particular buses means, the element will be 0. The element will be 0. So, which means that to find is, in this question, we need to find out the minimum number of branches in this system are. We need to find out what? Minimum number of branches. Minimum number of branches. So, in the question it is given as, what is the dimension of that Y-bus matrix? 1000 cross 1000. And also it is said that the number of elements, non-zero elements are 8000. how many number of non-zero elements? Non-zero elements are 8,000. So total number of elements in this Y-bus matrix is how much? 10 power 6. 10 power 6, and there will be 0 elements in that, and there will be non-zero elements in that. So we know that there will be 1000 diagonal elements. 1000 diagonal elements, and these are non-zero values. Non-zero values means some elements will be there. And the total non-zero elements are 8,000, right? So it will have branches, connection between ith node and jth node, or 1 and 2, you can say, whatever you consider. So the number of branches will be like what? 8,000. These are total number of non-zero elements, minus, for sure we know that there will be 1000 non-zero elements. So this is 7,000. This 7,000 is off diagonal elements. 7,000 is how much? Off diagonal elements. And we know that Y-bus matrix is symmetric matrix, right? Symmetric matrix means this off diagonal elements and this off diagonal elements are same. So the number of branches are the almost half of the diagonal non-zero elements, that is 7,000 by 2, that is equal to 3,500. So minimum number of branches in power system is 3,500. So the minimum number of branches in this power system is 3,500. Thank you.